Now let's get to the presentation. So we are grateful to have NASA Solar System Ambassador Joyce Jentges here with us tonight. Joyce is going to be telling us about the Mars 2020 mission of the Perseverance Rover. So go ahead and take it away, Joyce.
Thank you, Katie. As Katie said, my name is Joyce Jentges. Good job on pronunciation with the name.
Thank you.
I am a NASA Solar System Ambassador. I am also an amateur astronomer. I have been for a very long time. One of the main things that I do as an amateur astronomer is show people things in the night sky with my telescope. So being an ambassador for NASA is a little different. One of the main things I do with that is present things that are going on with NASA to the public. And I'm really excited to share with you information about the Mars Perseverance Rover, which will be launching later in July. As a NASA Solar System Ambassador, I am an unpaid volunteer for NASA, and I do just want to let you know that the views and opinions that I express here are my own opinions and views and not that of NASA. Okay, so let's go ahead and dive into this. So the goals of this mission are basically to check and see if there were ever signs of life on Mars. We already know that Mars has signs of water in the far distant past, but Perseverance is going to look for signs of microbial life and signs of habitable conditions in the past. It's also going to look at the climate and the geology of Mars and help prepare for further human exploration. It'll give us a better idea of what the actual geology and climate are like, and that will help us better prepare spacesuits and habitats for the harsh conditions on Mars. So this is a map of Mars stretched out, and you can see that this has all of the other Mars rovers missions that we have sent up there. And you can see Mars 2020 is right by that big black area there off center to the right. Mars 2020 is over to the right of center where that big black area is. And that area is actually called JEZERO crater. So why are we going to JEZERO crater? Do you see this next slide?
Yes.
Okay, excellent. So JEZERO crater was chosen as a landing site in November of 2018 after 5 years of searching for the best possible site to land this mission. The mission team pored over every detail of 60 different possible landing sites before deciding on JEZERO. And the reason they chose JEZERO is because they believe that JEZERO crater has the best possibility of finding signs of ancient life on Mars. So in this area, it's a 30-mile diameter impact crater. On the western side, there's a western edge where there's a valley, and scientists believe that that area once held water. There's also a delta, which is on the border of what used to be a lake. And these areas appear to have many features similar to what Earth has. JEZERO crater offers at least 5 different kinds of rocks as well, which also include clays and carbonates that have a high possibility of holding clues to microbial life. If there's clay, generally that means sometime in Mars past, there was water on Mars. And you see the next screen, Katie?
Yes, it looks like it's following along now. Yes.
Excellent. Okay. So this area of JEZERO crater, it's in an area called Isidis Basin, which is about 1,500 kilometers in diameter, an impact basin. It's also near an area of fractured terrain. The fractures came from the stress of the impact from the crater, and that caused huge cracks and faults. JEZERO crater was actually formed after the Isidis Basin, That area over to the left, Syrtis Major, that is actually a volcanic region nearby. It's thought that at one time there was at least one river, maybe two rivers, that were the result of possibly rain, ice, or snowfall that was in the atmosphere and somehow melted. At some point, the rivers drained into JEZERO crater, creating a lake nearly 250 meters deep. At some point, the lake overflowed the banks of JEZERO crater and flowed out over the rim of the crater. As they did that, they left behind sediment, which formed the deltas. So scientists believe that this area is very rich in materials and chemicals that could possibly point to ancient life in the far past. So let's move away from the actual area of JEZERO crater and start talking a little bit about the rover. Perseverance, several of you may remember in years past, we did send a couple of different rovers up to Mars, and one of them is Curiosity. Perseverance has a very different instrument suite from any of the previous Mars rovers. And part of that has to do with the amount of time since we last sent a rover up and the amount of time that's taken now to get us this far. Technology has come very far in between that time. So this rover actually has a larger hand, which is the turret on the end of the arm. It carries cameras and tools to be able to analyze chemicals and minerals that it finds. The wheels are also different because they're finding out that the wheels on Curiosity have not worn well. So in this picture, obviously Curiosity is on the left, Perseverance is on the right. Perseverance has twice as many treads as Curiosity, but they also don't have the chevron pattern. They're also made of a stronger material, which they think will help the wheels wear better over the very rocky terrain on Mars. Okay, so let's go on. We're going to talk a little bit about some of the different instruments on the rover, and I'm not going to go into a lot of detail. I want to start over on the right-hand side, which is the robot arm. That is the turret, the hand that I was talking about. And these all have really long, complicated names. I'm not going to go into those because they're tongue twisters. But what I am going to say about Pixel is that it's an X-ray fluorescence spectrometer. And this is going to help detect signs of past life by looking at textures and changes in the minerals that it finds. As you can see, it's mounted on the end of the robot arm. It does weigh about 6 pounds. And then there's another instrument on there. That one is also called Sherlock. This is another spectrometer, which will give us some fine scale imaging. And it also uses an ultraviolet laser, which will help detect minerals and other organic compounds. It will study minerals up close by using the spectrometers, a laser, and a camera. The instrument is also very unique in that it's going to carry small pieces of potential spacesuits so that the scientists can see how they weather on the harsh Martian environment. So along with Sherlock, there's also another camera right next to that called Watson. Watson can record and magnify textures of rocks and soil, and it's also able to take pictures of the wheels and other lower instruments on the rover, which will help scientists be able to assess its health. So if we move over to the left, there's something called MEDA, M-E-D-A. MEDA is basically a weather station on the rover. This is basically a set of sensors that can take measurements of the temperature, wind speed, direction of the wind, pressure, humidity, and also size and shape of the dust. The next one over on the bottom, we're going to start working around the bottom here, is called MOXIE. MOXIE is also a very unique instrument because what it's going to do is try to produce oxygen from the carbon dioxide in Mars' atmosphere. It's about the size of a car battery, and in the future, if we were to try to have a habitat on Mars, an instrument of this sort would need to be about 100 times larger in order to be able to make enough oxygen for an entire habitat. So now we're going to keep swinging around to the left. RIMFAX is actually underneath the rover. I've got a better picture of that right here. Over on the right-hand side, that red circle, it's that white envelope-like thing. So what that is that's actually radar. That radar can actually penetrate the ground and provide resolution of the geologic structure of the soil. And that's important because scientists think that in order to find signs of life on Mars, that they have to dig or be able to get somehow underneath the surface. So the next one, Mastcam Z, sorry. Mastcam Z is actually a camera system that has the ability to zoom. It's also on, you see that like hand sticking up with the head on it. It actually says Supercam. That's one of the other instruments on it. But Mastcam is actually up there on that hand as well. So this serves as the rover's eyes. At full zoom, it can see a housefly as far away as the length of a soccer field. So that's pretty strong. So the reason I left this picture in here, this is an instrument called Supercam. And you can see in this artist conception that it's shooting lasers at rock. So it will detect organic compounds in rocks and surface materials. It can fire its laser at rocks 20 feet away. And so it looks to see if any textures in the rocks or soil or chemicals have changed over time. It can also help measure the air, molecules, water, ice, and dust. It can also measure elements in the atmosphere that could be very harmful to humans, again, to help us better protect ourselves someday when we are ready to put a habitat on Mars. Okay, so let's go and we're going to talk about something else here, a different piece of the rover, and this is actually another one of the instruments, and I was really struggling to find a good picture that would convey what this is. So this is what they call the sample caching system. No rover or instrument that we've ever sent to Mars has been able to do what this is going to do. So essentially what happens, this has the ability to take up to 20 sealed samples from underneath Mars. It'll drill into the surface and set them aside so that they can be picked up by a future Mars mission and be brought back to Earth. And why is that important? Because we cannot send a laboratory large enough up with the rover to be able to significantly study the samples that we take. So in order to be able to study them, we have to be able to bring them back. So what it's going to do, in the belly of the rover, that's where the equipment is for this. So the big arm that reaches out on the rover is going to drill samples. There are 20 different drill bits on that. And then there's also a smaller arm in the belly of the rover, and that will pick up the sample tubes and hold them to be filled. Once they're filled, it's going to cap them and then stash them back underneath the belly. in a specific spot for those. Then later on, once it's completely finished taking all these samples, it's going to put them someplace on the surface of Mars to wait for that future mission to come back and bring them back to us on Earth. Well, so in order to make this happen, this whole mission, our technology has really had to evolve. We've had to create some very new technology in order to be able to make this mission happen. And I threw this picture in only because it's a really great picture to show you what the rover is going to look like once it's actually in the rocket, the different pieces of it. So the rover right now is sandwiched between these 5 different pieces here. So on top lists, it's what they call the cruise stage, and that just helps kind of hold everything in place. That white dome is called the aeroshell, and that's basically just a protective shell that fits over the descent stage vehicle and the rover. And then underneath, that brown dome underneath, that is basically a heat shield. And all together, when these pieces are snapped all together, and the rover is actually in space going towards Mars, that will help protect it from the different elements out there. And it will stay in that state until it is ready for launch. So one of the new technologies, in order to be able to get this rover down to the ground on Mars, they've developed a new technique, which is called range trigger. So what this does, looking at this picture, the blue ellipse, that is where they would like to be able to land the rover. The red ellipse is actually getting us, with range trigger, is able to get us closer to the actual landing site. So basically what range trigger does, it helps us to reduce the size of the landing area. This is also the part of the landing technology that releases the parachute. So the parachute is deployed based on where the spacecraft is and how close it is to the landing site. Why is that important? If we can get the lander and the rover closer to the landing site, it will spend less time driving to where it needs to go and more time doing science. In the future, it could also help other missions land closer to the spot where those cache samples are waiting for us to be picked up and brought back to Earth. One of the other new technologies is called terrain relative navigation. So this is, in essence, what this does. On the rover, there are pictures of the proposed landing area and other areas nearby. So as the rover gets closer, what it's going to do is it's going to take pictures of the area where it thinks it wants to land. And it's going to compare those to the pictures that it has on board. And if it decides that this is a hazardous area, like maybe it's a cliff or has a huge boulder, it can determine that it needs to land somewhere else and divert to a different area, which is pretty cool. We would not have been able to do that with any of the previous rovers. So in this, you see the helicopter there, and it's still in the protective shield. But once it gets ready to release the parachute, then that aerodome will eventually fall away, and the descent crane comes out, and then it will release the rover to land on Mars. So we're going to move away from the actual entry, descent, and landing and talk about a helicopter. Well, why does a rover need to have a helicopter? This helicopter is really different. It sits underneath the rover, and assuming that Perseverance is going to safely land on Mars, it will be deployed 60 to 90 days after the rover lands on the surface of Mars. And the sole job of this helicopter is to test powered flight on another planet. If successful, it could help us explore cliffs and caves and other areas that would be very difficult for a rover to get to. I threw this in partly because it's a really cool look at the underneath of the rover. Things are still like packaged up here. You can see that the wheels have protective packaging on them. But if you look down at that little red arrow, you see those blades sticking out there. That's actually the helicopter. I thought this was kind of cool because you can just see so many different things underneath the rover. It makes you really appreciate all the work that went into the actual rover. So the helicopter actually has a name. The name of the helicopter is Ingenuity, and that was named by a high school student by the name of Vanessa Rupani, and she lives in Alabama. She actually submitted the name Ingenuity for the Mars rover, and it was in the top 9 names for the rover. NASA decided that this would be a perfect name for the helicopter. So she had to write an essay, and in that essay she wrote, "The ingenuity and brilliance of people working hard to overcome the challenges of interplanetary travel are what allow all of us to experience the wonders of space exploration." Now, I've mentioned that the name for the rover is Perseverance. Well, how did it get that name? Last year, NASA held a contest to name the rover. It invited students in grades K through 12 to write a short essay about why the name they chose should be picked for the rover. So the young man that won the contest, his name is Alex Mather, and he lives in Burke, Virginia. So he wrote about Perseverance. "We are a species of explorers, and we will meet many setbacks on the way to Mars. However, we can persevere, not as a nation, but we as humans will not give up." And ironically, when you look at 2020 and how this year has played out, Perseverance is actually the most perfect name that we could have given the rover. The mission team, actually, when the coronavirus hit and things began being locked down, NASA decided that only those that absolutely had to be at their sites could be there. Everybody else had to work from home. So the mission team for this rover, we have people working around the globe to get this rover off the ground. So they have had to figure out how to work as a team from home, like a lot of people have been doing recently, trying to build a home office and be able to work at home without distractions and that kind of stuff. So I really do think that the name Perseverance was probably the most fitting name that could have been chosen for the rover. And I want to show you a fun thing here. So also last year, they had, and they're doing this again for a rover that's going to be going up in 2026. They had this thing out there on social media saying, "Send your name to Mars." Well, so I sent my name in, and it turns out that I wasn't the only one that sent my name in. There are over 10 million names that are going to Mars with the Perseverance rover. And that red arrow, this is this white bar, is a bar that's on top of the rover. That red arrow, oh, I did it again, points. That red arrow points to 3 little chips that have every single one of those 10 million names engraved on it. And so when you sign up for this to send your name along, they send you this really cool boarding pass. So that's a picture of my boarding pass. I think it's really kind of cool that they do this because it's a fun way to get the public involved in stuff like this. Well, so now that I've told you mostly about the rover, I actually want to talk a few minutes about the actual launch. So Perseverance was actually supposed to launch July 17th, and it has been pushed back a couple of times. Recently, it was pushed back because they found an issue with a liquid oxygen sensor line. And they found this during one of the dress rehearsals that they do. So the issue has since been fixed. And on July 7th, the rover was actually placed in the nose cone of the rocket. The rocket is an Atlas rocket, much like what you see here. So it'll be in that top portion of the cone there. Right now, the scientists are doing some electrical work because basically they put the cone just a couple of days ago on top of the rocket, and now they have to basically mate the two pieces together electronically to make sure that everything is working together in sync. So these connections, they're going to stay in place for about 50 to 60 minutes after launch, when Perseverance actually separates from the nose cone. So for now, the mission team is actually going to begin the final testing of the two pieces, both the nose cone separately and the whole rocket with the nose cone attached. And the exciting thing here, as we're getting closer, on the 28th of July, the rocket will actually move out of the launch facility that it's in and move down the road 1,800 feet to the launch pad. It's going to launch from launch pad 41 at Cape Canaveral in Florida. And right now the launch window runs from July 30th through August 15th. So that means that if the weather's bad on July 30th, they do have several different attempts each day where they can try to launch the rover. But if we get a series of bad weather or technical issues, we hope that it doesn't have to be delayed much longer. Because if they have to delay it past August 15th, then we might run into some problems getting it to Mars in a timely fashion. One of the reasons why they're launching the rover soon is because Mars is closer to us than it normally is. If it's closer to us, that means it's going to take less propellant and energy for the rover to get to Mars. So if they miss this launch window, they're going to have to wait a pretty long time before they can actually launch this again. So I feel pretty confident, being that they have several windows each day where they can launch. I'm pretty confident that the rover will actually launch during this time period. And, you know, I was talking about the rover being put in the nose cone. I just ran across this picture about an hour before the presentation, and I decided that this was so cool, I really needed to add it. So you see the blue and white sections. Those are the two main pieces of the nose cone, and the rover is that small domed piece that sits right underneath it. It's actually upside down right now with the heat shield up. So they have gotten that actually into the nose cone, and the nose cone has been put together and is now sitting on top of the rocket. But I thought that was really just a really, really cool picture. So I believe that Perseverance is probably the most daring mission that NASA has ever attempted to send to Mars or pretty much anywhere else in the solar system. They've had to create new technology in order to be able to make this mission happen. Perseverance is going to show us things about Mars that we've only dreamed of. So I'd like you to join me on July 30th as we cheer on Perseverance as it takes off for Mars. Do you have any questions?
All right. Thank you, Joyce. I don't see any questions in the queue right now, but we'll give a little time to type those up. Again, you can type your questions into the chat, or you can unmute yourself and ask a question via the audio.
Okay. Should I stop sharing my screen?
It's up to you.
Okay.
I did have a question. So you mentioned that the Perseverance is doing this testing, and it might be beneficial when we build a future habitat on Mars. Is that, I don't know if that's the exact wording you used, but what did you mean by that?
Well, so one of NASA's long-term goals first is to build a habitat on the moon. Okay. It's going to be hard enough to build a habitat on the moon without even thinking about Mars. Right. Mars is far, far, far in the future. Currently, right now, Mars is working on a program called Artemis, which will take us back to the moon for the first time in over 50 years. And I haven't had a chance to really dive into the Artemis program. So I don't know that a habitat is going to be the first thing we do once we get back to the moon, but it will come eventually. And one of the reasons we're looking at doing that is because the moon is a good stopping point before we head on to Mars. If we have some sort of a stopping point on the moon, it would be a good stop for us to be able to maybe pick up supplies, pick up passengers, try to fix any problems that may have occurred just getting to the moon. And really, atmosphere-wise, I mean, the moon doesn't really have much of an atmosphere, neither does Mars. If we start by trying to build habitats on the moon, we have to figure out how are we going to get water there? How are we going to get oxygen? How are we going to be able to move about on the moon? Are we going to have vehicles? Any kind of transport? How do we build things on the moon when we have to bring all the materials with us?
Right.
So it's a stepping stone on the road eventually to habitation on Mars.
Okay, wow, that's so interesting.
Anything else?
Any other questions? I thought it was super cool that you put your name in to go up to Mars. I wish I would have known about that.
It's pretty cool. They did it for the Parker Solar Probe, which launched last year. And so my name is flying along with that too. And just today, I saw the one for whatever the next Mars rover is going to be going up in 2026. So eventually I will probably sign up for that one as well. It's kind of cool.
It is, yeah. I'll keep the 2026 one in mind.
Okay, sounds good.
All right, so if there are no further questions, we'll go ahead and end the presentation. Thank you so much, Joyce. We really appreciate it. It was very interesting, and I hope to continue collaborating with you in the future to learn more about what NASA's up to.
All right, thank you.
All right.